Angles formed by tangents, chords, and secants. The measure of an angle formed by two secants, a tangent and a secant, or two tangents intersecting outside the circle is half the difference of the intercepted arc. So in my first diagram, I have two secants. The angle itself is angle P. So if I trace out angle P, it touches the circle between arc AB, keep extending, point C, and point D. So it'd be half the difference of CD minus AB. It's always going to be the big minus the small. In the second diagram, angle P is outside the circle. And if I trace out the angle, it touches the circle at A and at B. So PA is a tangent, that's arc AB. I can't go out any farther from PA because it only touches the circle one time. So the second arc would have been CA. The big one is CA and the small one is BA. If I have two tangents, angle P, if I trace out, it touches the circle at A and at B. So I have small arc AB and big arc AB, which we're going to call ACB. Okay. Let's try some examples. Okay, so since I have two tangents in the first picture, if one of the arcs is 260, then the remaining arc must be 160 because the whole circle has to add up to 360 degrees. So angle A will be half the difference of 200 minus 160, which would be half of 40. So angle A would be 20 in this picture. Now on the party hat question only, so on the party hat only, the angle and the minor arc, so the minor arc plus the angle will always be 180 degrees. It's a little Jeopardy trivia if you notice it. If you don't notice it, then we just use the rule. Okay, in number 2, it looks like I have two secants. So angle A will be half the difference. If I trace it out, it touches the circle 30. Keep going. And 70. So it'll be half the difference of 70 minus 30, which is half of 40. Coincidence only that I get the same number, which is 20. Now, in number 3, it looks like I have the angle, and I'm looking for the arc. So remember, the angle is half the difference of the big arc minus the small arc. So if I'm going to solve for arc BC here, I think it's easier to get rid of the 1/2 by multiplying both sides by 2. Otherwise, I know I could distribute. But 1/2 times 2 will get rid of the 1/2. So it looks like 40 equals 120 minus arc BC, if you prefer to put x there, because it's easier to solve than just put x. And it looks like if I subtract 120 from both sides, I get negative 80 equals negative BC. So that means I know that positive 80 equals positive BC. So the measure of arc BC must be 80.